Okay, so today let's just discuss about the rotational motion and for Malaysia universities. All right, so what is about rotational motions? I think you've learned like for the linear motion where a particle move in a straight line, and this is called linear motion, right? And also we learned that when someone's central face and then they turn around and the displacement will be zero, but you still have the motion, and this motion is called a rotational motion, and that's what we're going to discuss for today. This video is when there's a rotation, the motion associated with it. All right. So actually, it's quite similar to the linear motion. Okay. So actually, just borrow from the linear motion, and then we just change all the thing into all these symbols. All right. So it might get a bit confusing if you're first time learning it. So very simple. So when a ball is moving in a circle, let's say a pendulum, all right, and it moves in a circular motion, all right, and then when it turns, so even though the displacement will be zero, all right, but actually there's a movement. So the movement is right now is in terms of the angle, all right, okay. So the angle right now is in the unit of the radian. Okay. So right now the displacement move is calculated in terms of the theta, and the unit is in radian, right? Also, it moves with speed, and this speed is called the angular speed, or angular velocity, or angular speed. And the symbol is like this, like an omega. And since we have the distance in the angle over the time, so the unit for this one will be in radian per second, right? Or sometimes in other unit based on the revolution, means one turn here one time is called a one revolution. Okay, and next also S is angular acceleration, right? And this is very similar to the acceleration. So angular acceleration is like this, an alpha, and its unit is radian per second squared. So since it is quite similar to the linear motion, so we can use the same formula for the linear motion and make it into the rotational motion. As you can see, velocity right now is become this symbol is angular velocity. All right. Here V change to this omega. With the A become the alpha. T is still the same. This is a change of displacement, but here is a change of the angle. Same V become the angular speed omega, and so forth. A become omega, and so forth. And we have all the formula here, and we are using all the formula to do the calculation. Actually, is quite simple. As you can see here, actually is given like for formula how to pick, right? Always you confuse like there are 1, 2, 3, 4 formula, but you will confuse like which one should you choose, right? Okay, actually very simple. For me, it based on what thing it needs and what thing I have. A very simple. For example, let's say I say this is one item, omega f and omega I are different thing, and alpha is another thing, t is another thing. So here we got 4 things. Okay, so actually it's just like it's given using the formula. It's given 3 items, all right? Given you 3 items and find the one that's missing, all right? Let's say it's given this one, this 3, and need to find the time. And alternatively, it gives this one, this one, this one, and asks you to find the final angular velocity. Or they give you another one and ask you to find the other one. So as long as at least you have 3 information, all right, and one thing that you need to find, and that's how the strategy. Okay, so later I'll show in detail for the example how given the 3 items, then we can select the formula. So let's look at the example right now. Okay, so here rotating view A, view rotates with a constant angular velocity. All right. So we can, based on here, we can take a mark constant acceleration. So we can write it down for the things we have. Angle 3.5 radian per second squared. This is our first information. If the angular speed of the wave is 2 radian per second, at ti, the initial time is 0. All right. We have, when the time is initial, of course, this angular speed also initial. So put it here, is 2 radian per second. Okay, cool. Angular speed, this one. And the first question, through what angle does the wheel rotate in 2 seconds? Right here, given in 2 seconds means that our time in equal 2 seconds. And what we want to find? What angle? You see here, what angle? So we are finding this thing. Equal to what? So as you can see here, how many things we have? 1, 2, 3, 4. 4 things. So we pick up the formula with this 4 symbol. All right. So we need time. Okay. So here got 1, 2, 3, 4 formula. As we quickly remove this one, okay, since this one doesn't have the time. All right, this one we don't need it. All right, we don't need this one. And we have, and we need the data here. So the first one doesn't have the data, so we don't want this one. So we left 2 and the 3, the 2 and 4, sorry. So what we want, do we have this one, right? But we don't have this one. We don't have this one. So same. So we don't want this one. Therefore, we use the second formula. You can see that it's quite simple to use. Which formula is this formula? Okay. Okay. So therefore, we're going to select this equation. Very simple. We just insert the thing into the formula. Okay. So this is the thing we want to find, and this one given 2 times 2 plus half, and this is 3.5 and 2. All right. And calculate. And you will get the answer, which is equal to 11 radian. Okay, cool. And next, you want to find what is the angular speed at time equal to t 2 seconds. All right, so still the same. This one is 3.5. This one is 2. Time is 2. And right now it's angular speed at this one. Means the speed after 2 seconds, which is this is what we're going to find. All right. So which formula do we want to choose? Okay, you can try it out. Okay, we need the time. So this one, we don't need it. And we don't have the data. So here data and data cancel out. And this one is what we need. Okay, so very simple, just substitute. So I use different color. Okay, it's equal to 2 plus 3.5 and 2. And we can get the answer, which is 9 radian per second. Okay, very simple for the first example. And we look at next. Okay, example number 2. So we need to find that during a certain period of time, the angular position of a swinging door is described by this one. All right, so as you can see here right now, is this in terms of formula, which is not usual given the number. Okay, so and this one is we need to find, if you see something like this in terms of all things in terms of t, means that we're going to do it in terms of the differentiation method. Okay, if you see something like this, or sometimes even like it's in terms of t, means you're going to do the differentiation and the integration. So as you see, we already know that displacement, if we differentiate it, we'll get velocity, right? And same if for the data, if we differentiate in respect to time, and we will get, yes, the angular speed. And we differentiate one more time, and we get the angular acceleration. Okay. So this is not so difficult. Right now, you want to find the angular position first. Angular position means the theta, omega, and the alpha. At time 0, time equal to 3, and etc. So find the angular position first at time equal to 0 for A. Then we just substitute here at 0 and here at 0. So it's just 5 radian. Okay. And next, we're going to find the angular speed. Then we differentiate one more time, differentiate one time. Since v equal to d theta dt, means we differentiate this whole thing. Differentiate 5 is got 0. Differentiate 10, we got 10t, we got 10. Sorry, 2t squared, and they got 4t here. All right, so no need the 0 here. So this is the formula for velocity. Sorry, not velocity. Is the angular speed. All right, this is good. This one. And we substitute the time is 0 here. That means this is equal to 10 radian per second. All right, simple. And next, we're going to find the angular acceleration. Then we differentiate the angular speed one more time. Different 10, we got 0. Different 40, we got 4. That means that the angular acceleration is constant. Right? If we substitute 0, it doesn't have t for us to substitute, whereby it's always 4 radian per second squared. Okay? And right now we just do for the b when time equal 3. So we just substitute 3 here. Very simple. Substitute 3 and 3, and we got an answer. Okay? And try stuff. And here also substitute 3, and this doesn't have 3 substitute, and this is the same as also 4 radian per second squared. Right? This one, no need to use the formula here, because this is not the usual one. Okay? Because it's given you the formula already. Unless it's given in the number, then we can use this formula again. Okay. Right now we look at the next question. An electric motor rotating a rearing wheel at 100 revolution per minute. Okay, here, gotta be very careful because okay, we switch off. As you can imagine, like a wheel, example like something like a fan, we switch off. Then it started from this speed is 100 revolution per minute. But you have to be very careful, but it's because the unit, all right? The unit is not in terms of the radian per second. So we need to accommodate. Okay. So one revolution is actually equal to, like one circle is 2 pi. Okay. So here 100 times 2 pi. And then per minute become 1 minute is equal to 60 seconds. And divided by 60. And when you do the calculation, I make it simple, maybe 200 over 60 pi. And then I use this number to put in my calculation. Okay, so I write it here nicely. My initial angular speed is 200 per 60 pi. All right, just gotta be very careful. Okay, and the unit is radian per second right now. And next, with constant negative, okay, very important, negative angular acceleration means, okay, is negative 2 radian per second square. Okay, so we look at question A. How long does this take the wheel to stop? Okay, how long means the time. How long? All right. Okay, not the length. Okay, and one important thing here, we have 3 information here. We need one more. Okay, which is, and what is the another information here? The wheel to stop. When something stop turning, it means that its velocity is 0. All right. So here we get another piece of information. So we have 4 pieces of info. Okay, and right now we're going to select the correct formula. So which formula do we need to use right now? So we don't need the data here. So this one, no need. And here also got data. So we don't need the data. All right, just this one. Cool. So we just substitute the thing. 0 equal to, this is 200 over 60 pi. And then plus, all right, remember to put -2 and time. Okay, and the time is equal to 10.5 seconds. Okay, and this is A. Around we do B. And B through how many radians does it turn while it's slowing down? So means how many radians? Means the unit in radians, so means that this is the angular, the change in the angle. Okay, how much? And we slow down. Same. Also when the speed, the speed is 0 radian per second. Okay, right now we need the data here. All right, we don't need this one. We need the data. And what else we have? I think a lot of things we can use. We don't have the time. All right, right now we don't have time. So the formula 2 has a time. So, okay, formula 2 has a time, and 4 also have time. So we don't need the time because we don't have a time. Okay, and we use the formula 3. It's just substitute 0 square equal to 200 plus 60 pi square plus 2, negative 2, and the change of the data, and we can find the answer. Okay, 109.7 radian. Okay, cool. And next, the wheel turning with angular speed of 30 revolution per second. Okay, rest. You need to be very careful. Angular speed, and the unit is not in radian. Okay, 30 revolution per second, which is we convert to radian, means times 2 pi for it becomes 60 radian per second. Okay, and brought to rest means the final velocity is 0 with a constant acceleration. All right, it's not given. We need to find out. And it turns 60 revolution. This is important. Yes, this is our data, or maybe change of data based on formula. 60 revolution. Okay, times 2 pi also. We have 120 pi. Okay, in radian. Okay, so which formula do we need to use right now? And we're going to find out this thing. Okay, we don't have the time here. Okay, all the formula time cancel out, cancel out, and cancel out. Okay, we just take this one. 0 square equal to 60. Sorry, with the pi. Sorry, 60 pi. My bad. 60 pi square plus 2 times the thing we're going to find, and 120 pi. Okay, okay. So what do you find? Because as you can see, it starts from 30 and becomes 0, means that the acceleration should be negative. Okay, so negative 47.1 radian per second square. Okay, so this is simple. Let's try the last one. A flywheel has, which is originally at rest. Okay, very important. It means initial speed is 0. Has reached angular velocity of 60 radian per second. Okay, in 6 seconds, not sine. Okay, no, this is a very simple one. 36 radian per second. Time in 6 seconds. Oh, what we'll find? Angular acceleration. Okay, very simple. Just take this one. 36 equal to 0 plus omega times 6. So what is it? Right, 6 radian per second squared. And that's it for this part. And next we're going to move on to part 2 for the rotational motion. How relate to the speed, the displacement with the linear motion.